Let us now study electrostatic potential at a point due to an electric dipole. So first let's take a dipole. A dipole has two charges. One is a negative charge, I'll draw it here. So let the negative charge be minus q, and we have a positive charge. Let the positive charge be plus q. They are separated by a distance. The distance is 2a. Okay. So let this be the axial line, and this is a midpoint O, and this distance is a. This distance also will be a. Now we consider point P. Okay. Let's take a point P at some distance from the origin. So let the point P be here. Okay. So point P is at a distance from the origin. So let the distance between this origin and the point P be r. Okay. And then let the distance from positive charge to point P, let this distance be r1, and let the distance between the negative charge and point P be r2. So this is a negative charge here. This distance is r2. Now the angles. So let me take another color here. So let this angle is theta. So what will be this angle? This will be 180 minus theta. Now let us name the points here. Okay, this one I'll name it as A, this one is B, and as you know, this point is O. Okay, so we must find what's the potential at P here. What's the electrostatic potential at the point P? So for that, let us take the potential due to the positive charge here. Okay, so electric potential to positive charge, I write as V plus, that is equal to 1 by 4 pi epsilon naught into q by r. This is the electrostatic potential, but you see the distance here is r1, so q by r1. Now same way, the electrostatic potential due to negative charge, that is V minus, is equal to 1 by 4 pi epsilon naught into q by r2. Now let us see the total electric potential. That means you must add both the things. Okay, but if you see this is a negative charge now, so you must write minus sign here. So total potential, V total, that's equal to the potential due to positive charge plus the potential due to the negative charge. That will be 1 by 4 pi epsilon naught into q by r1 minus 1 by 4 pi epsilon naught into q by r2. Now let us see what's the common term here. Q by 4 pi epsilon is common, so I'll take that out. So q by 4 pi epsilon naught into 1 by r1 minus 1 by r2. This is the total potential difference, V total. I'll name this equation as 1. Okay. Now we must find what's 1 by r1 and 1 by r2, then we can get the value. Now we must find what's 1 by r1. So for that I'll take the triangle BOP. So take the triangle BOP. So as that, you can see here BOP. So I will draw the line separately now. So triangle BOP, we'll draw it here. This triangle, this is angle B, this is position B, O and P. The angle here is theta. This distance is r1, this is r, and this is a. Now we must find r1. So for that we have a law called as cosine law. Okay, so using cosine law, this is a new thing which you are learning. Cosine law, it states that if you take any triangle, its sides may be ABC, then a square is equal to b square plus c square minus 2bc cos theta. Okay, I'm going to use this cosine law now. So let's see that now. So same way, instead of a square I'll write as r1 square. So you have here r1 square is equal to, this side you will have r square plus a square minus 2RA, instead of BC we are writing 2RA, into cos theta. Now we can take r square common out. Okay, so what happens is we get r square into 1 plus, so because r square has gone out now, and then we have a square by r square minus 2RA cos theta by r square. Now if you notice that r and the square will cancel. One more thing you notice that r is much more bigger than a. Okay, the distance is much more bigger than a, so you neglect this a square by r square, this term. Okay, this term can be neglected. So what happens is we get here r square into 1 minus 2a by r into cos theta. Left side will have this r1 square. Now we must remove the square root, so we take square root on both sides. So take square root on both sides. So what we get is we get r1 is equal to r into 1 minus 2a by r into cos theta power half. Okay, but our aim is to find what is 1 by r1 only. So let us find what is 1 by r1. 1 by r1 can be found by taking the reciprocal of the last equation, that is 1 by r is equal to, sorry, 1 by r1. 1 by r1 is equal to 1 by r into that value, that is 1 minus 2a by r into cos theta power half. So I'll extend it thing, this power half. Now you take this full term to numerator, it will become power minus half. So let me write that down. 1 by r1 is equal to 1 by r into 1 minus 2a by r cos theta power minus half. Now we can use binomial theorem here. Okay, using binomial theorem. Using binomial theorem, let us see what we get. So in binomial theorem we can use that formula 1 minus x power minus n, multiply inside, so 1 plus nx, neglect the higher terms. So I'm going to use it here. So we have here 1 by r1 is equal to 1 by r into 1 minus, or in this case minus and minus become plus, plus 1 by 2 into, say this is n, okay, this is n and this is x, so I brought this n inside, so into 2a by r into cos theta, so 2 and 2 will cancel, so we left with 1 by r1 is equal to 1 by r into 1 plus a by r into cos theta. So let us name this equation as 2. Now we must find what is 1 by r2. So for that I'll take the triangle AOP. So take the triangle AOP. So triangle AOP is picture, will see it back. Now if you see, this is triangle A, O and P. Okay, let me draw a triangle separately now. Okay, let me draw a triangle here. This triangle here. This is triangle A, this is O, this point is O, this is P. This angle here, the angle is, that is 180 minus theta. This is R, this will be R2 and this will be A. This is R2. Our aim is to find what is R2 now. So we'll use the cosine law again. Okay, using cosine law. So cosine law, that we know that a squared is equal to b squared plus c squared minus 2bc cos theta. I'll use this formula here. Okay, this is a cosine law. I'm going to use it here. So we need to find R2. So we write as R2 square is equal to R2 square is equal to R square plus a square minus 2RA into cos of, now you see the angle, that is 180 minus theta. Okay, now what is this cos 180 minus theta? That is minus cos theta. I'll write here cos 180 minus theta. If you notice that, that is equal to minus cos theta. Okay, so instead of writing cos 180 minus theta, I can write as minus cos theta. So we get here R square plus A square minus into minus will become plus now. So plus 2RA cos theta, that is R2 square. Now again we can take R square common. So R square into 1 plus A square by R square plus 2RA into cos theta by R square. R and the square will cancel. Okay, neglect the similarly neglect A square by R square. So you get here R square into 1 plus 2A by R into cos theta. Left side you get R2 square. Now you take square root on both sides. Okay, same steps like other one only. So take square root on both sides. Okay, so what happens is we get R2 is equal to R into 1 plus 2A by R into cos theta. Square root means power half now. Okay, but our aim is to find what is 1 by R2. So let us find 1 by R2. So take reciprocal. 1 by R2 is equal to 1 by R into 1 plus 2A by R into cos theta power half. Now we take this term up, it will become power minus half now. Okay, let's do that now. Okay, let me write that down here. 1 by R2 is equal to 1 by R into 1 plus 2A by R into cos theta power. Now this becomes minus half. Okay, again use the binomial theorem. Okay, let's use the binomial theorem here now. Right here, using binomial theorem. Okay. So in this thing we'll use the binomial theorem, that is 1 plus x power minus n, that will be 1 minus nx. Okay, now if you notice this is minus. Okay, minus into plus will become minus. So I'll use the equation here. 1 by R2 is equal to 1 by R into 1 minus n. N is, we had this half, you can see that. Okay, into 2A by R into cos theta. Now 2 and 2 will cancel. So what we left with is 1 by R2 is equal to 1 by R into 1 minus A by R into cos theta. This is equation number 3. Okay, so now we got 1 by R1 and 1 by R2. Let's substitute in the first equation. So substitute in equation 1. Okay, the terms for equation 2 and 3. Okay, let's substitute that. So what happens is equation 1 we got, that is V total is equal to Q by 4 pi epsilon naught into 1 by R1. 1 by R1 we got, that is 1 by R into 1 plus A by R into cos theta. This term we got now. Now we must write that minus sign now, because 1 by R1 minus 1 by R2. Okay, let's write that now. Minus 1 by R and this term now. Okay, 1 minus A by R to cos theta. Now if you notice that 1 by R is common here, so I can take 1 by R out. So let me write that down. So what we have is Q by 4 pi epsilon naught into R. So R is coming out, and then we have here 1 plus A by R into cos theta, and then multiply the minus sign inside. So minus into 1 is minus 1 and minus into minus is plus. So plus A by R cos theta. Now if you notice that plus 1 and minus 1 cancels. So this term is same only, so you can add them. So what we get is Q by 4 pi epsilon naught R into 2A cos theta by R. Now R into R is R square. We can rearrange and write. Okay, let us write that down. Let us rearrange and write now. So what happens is we get 1 by 4 pi epsilon naught. Left side we have V total voltage, that is, or the total potential difference, into 2QA by R square. So R square into This is A cos theta. Okay, so 2qa by r square into cos theta. Now you know that 2qa is dipole moment, that is P. So dipole moment P is equal to 2qa. Let me write that down, use it now. So we have here V is equal to, we have here 1 by 4 pi epsilon naught into P cos theta by r square. So this gives us the formula for the potential at a point due to an electric dipole. Now let us see some special cases. So let's see special case here. First special case. Special cases. First one. For that we will go back to the picture. Okay, the first special case is the point P lies on the axial line near positive charge here. Okay, here. So the angle theta will become as 0. Let us see what happens now. So special case first one is P is near, the point P is near plus Q. So angle theta becomes as 0. So let's see the equation here. What's cos 0? Cos 0 is 1. So voltage will become as V 1 by 4 pi epsilon into P by R square. Let me write that down. So we have here voltage is equal to, or the potential is equal to 1 by 4 pi epsilon naught into Q by, sorry, this is P by R square. Okay, this is the first special case. Let's see second one now. So second case is that we take the point to be on the near the negative charge. Let us see the picture here. Okay, now the point P is near negative charge here. Okay, so in this case the angle, if you notice that this angle theta will become as 180. We're seeing theta only, not this one. So this one, if you notice it becomes 180. Okay, so point P is near minus Q. So second case is that the point P is near minus Q. Okay, so it's near minus Q. What happens? Okay, theta is equal to 180. Cos 180 is minus 1. Okay, if you notice in the equation here, cos 180 is minus 1. So we get here V is equal to minus 1 by 4 pi epsilon naught into P by R square, where P means dipole moment. Okay, now let us take the third condition. Third condition is the point P is on the equatorial line. Okay, P is on the equatorial line. Okay, if point P is on the equatorial line, what happens? Okay, what will be the voltage? We'll see that now. So we'll go back to the picture. So point P is on the equatorial line, means it's exactly here. Okay, in this case theta will become as 90 degrees. Let's see the angle now. Theta is 90 degrees. So in this case theta is equal to 90 degrees. Let's see the formula here. Okay, V is 1 by 4 pi epsilon P into cos theta by R square. So cos 90 is 0. So this full term becomes as 0. So potential becomes as 0 here. So these are the three important special cases.